You're live.
Good evening, everyone. We're going to give it a couple minutes to see if a couple more attendees come in. Good evening, everybody. I'm Jim Lyons with the U.S. Department of Agriculture, Natural Resources Conservation Service. Here with me tonight from NRCS is also Darren Davis, the State Conservation Engineer for Massachusetts. And welcome to the second public meeting for the Allen Dam site. The town of Walpole requested NRCS's assistance back in 2015 for rehabilitation of the Allen Dam site. And the purpose of this meeting tonight is to present to the public the analysis that were conducted on the Allen Dam and the alternatives that were examined for rehabilitation of the dam. In addition, please, we ask any questions that you may have, and we will listen to any comments that you may have. And at this time, I will turn it over to the owner and the town engineer, Carl Baldoff.
Good evening, everyone. Carl Baldoff with Walpole's Department of Public Works, town engineer. I'm here with Jim Johnson, town administrator, as the owner. And I've been working with NRCS, Jim Lyons, and NRCS's engineering team, DDK Engineering, on this project for the last year or so to come to the point where we are tonight. So we're here. We've been working with NRCS. This is a town-owned dam, but NRCS has come in to do the work to bring this back to standards that will last for quite a while longer. On that note, I'm going to turn it back to Jim Lyons. Thank you.
Tried to get myself off of mute. The presentation will be done by DDK Engineering, and I'll turn it over to Jeff Tucker with DDK, and he'll introduce the DDK team. Thank you very much.
Jim, thank you, and good evening, everyone. My name is Jeff Tucker. I am the project manager, and with me tonight is Emily Lewis, our senior environmental planner.
Good evening.
And Charlie Johnston, our project engineer.
Good evening.
We're going to stop our videos, and Charlie, if you would advance to slide 3, please. And one more. So as Jim said a couple of minutes ago, and we've been working on this project for about the last 12 months. And so the objectives of tonight's meeting is to first just review the basic project steps and background. We want to review the purpose and need of this project. We're here to present alternatives, summarize the alternatives that were carried into detailed study, and then to present and discuss the preferred alternative. And then associated with that preferred alternative, Emily and Charlie will review the environmental impacts and the cost benefits of this. Next slide, please. First, to orient everyone to where we're talking about, this is, of course, the Allen Pond Dam. And you can see on your screen where we have in blue, where we've labeled Allen Site Dam, and that's got an arrow down to the blue line. That's the top of the earth embankment. You'll notice, or you'll see Washington Street just to the left of that. And the dam, the pond itself is underneath the words Allen Pond. It's kind of this image was taken in the summer, so there's a lot of vegetation and up. And you'll notice the fairways of the surrounding golf course here, and then the highway that's a little bit further to the south-southwest. You'll see the slide in a few more minutes. Next slide, please, Charlie. One of the important components of these watershed studies, because this is federally funded and it goes through the National Environmental Policy Act, or NEPA, is to prepare a purpose and need. So we've done that, and the purpose of this project is to provide the originally planned level of flood protection to the watershed for the next 100 years, while minimizing environmental, economic, and social impacts. The need of the project is that the present dam structure does not meet current safety and performance standards. Therefore, action is needed. Action is needed to reduce the risk of flood damages to homes, commercial facilities, and an expanded infrastructure, and to reduce the risk of loss of life due to a potential breach of the existing dam. Next slide, please. So, dam rehabilitation, planning, and implementation process. This project goes back a number of years, and there is a specific process through, and we're in number 4. We're in the planning portion of this process. And that process is for the selection of a preferred alternative. A preferred alternative meaning this is what we're expecting to design and advance into construction down the road. And the next step after this planning process, which is expected to be completed in around the July of 2021 timeframe, so 8 to 9 months from now, then it would be followed by the final design and then construction, which is tentatively scheduled for the summer of 2023. Next slide, please. So as a brief recap here, back in 2015, NRCS completed an assessment of this dam. And they completed this assessment because the dam is approximately 40 years old, and they wanted to check in as part of their process. And the outcome of that identified that there were some issues, nothing of significance, but mostly issues that will extend the safe use of this dam for the next 100 years. So the town requested assistance, federal funding assistance, working with within the NRCS program. And in May of 2019, the project was advanced, funding was secured, and the project went into the planning phase. We came on board back in September of 2019. This past January 14th, Charlie and I and Darren, Jim, Carl, all of us were at Town Hall, where we made the first public informational presentation of this project. That same day, we also had our first scoping meeting with various government resources and agencies. And at that meeting, we laid out what the purpose of the project was and the alternative formulation process. And we also indicated that we'd be spending the summer and into the fall identifying and evaluating alternatives, in that we would be coming back and presenting these alternatives to the public in late fall. So here we are on the 17th doing just that. Next slide, Charlie. So what are some of the next steps after tonight's public presentation? Well, we'll be issuing several levels of drafts of the environmental document that follows the NEPA process. And that once that has gone through the internal NRCS review, that will ultimately be issued to the public as a draft document for the 60 to 90-day review process. Those comments come back in, the document is finalized. Once that document is finalized, the town affirms what it wants to do. And if it is indeed the preferred alternative, then the design phase would ensue. Once funding was in hand, and then construction would follow after that, again, the late 2022-2023 season. Charlie? So Charlie Johnston, our project engineer, is going to walk us through some of the specifics of the dam. Charlie, you have the floor.
Good evening. My name is Charles Johnston. I'm a project engineer. We just want to give you a brief background of Allen Dam. It was constructed in 1981, approximately 39 to 40 years ago. It was constructed for flood control for the town of Walpole. It's located just southeast of Washington Street on the Diamond Brook or Spring Brook, as it's often referred to. It's an earthen embankment dam, approximately 1,500 feet long and 21 feet tall. It consists of a two-stage concrete principal spillway structure, outlet pipe, and outlet works, and with a earthen auxiliary spillway. As Jeff described earlier, this is a watershed map depicting the overall watershed that flows to Allen Dam. And the blue line, there is the location of Allen Dam. On this next slide, we're going to provide a enlarged view of Allen Dam. Just turn on my pointer here. This is the dam embankment right here, which is just southeast of Washington Street. This is the impoundment, which continues southeast towards the Walpole Country Club, and the earthen auxiliary spillway to the left of the dam. I want to show you a typical cut view of a earthen dam to identify key components of the dam. We have the impoundment, which is the pond or reservoir behind the dam, the concrete structure and trash rack, which controls the normal water level and typically has a drop inlet for higher flood events. And that discharges through an outlet pipe to the outlet works, which discharges downstream, and an auxiliary spillway, which controls flow for larger flood events, such as the 500-year flood event. We have a few photos of Allen Dam. This is the top of the embankment, extends all the way down to the back of the photo. On the left is the pond or reservoir, and on the right is the downstream slope and toe of the dam. In the background, you can see the principal spillway riser structure. In the upper right, we have the principal spillway riser structure drop inlet, crest, and trash rack. Water would flow into this in the 100-year storm or 100-year flood through the outlet pipe and discharge out through the outlet works in the lower left photo. And Spring Brook would reestablish and then flow under Washington Street in the back of this photo. In the lower right, we have the earthen auxiliary spillway. Allen Dam is safe and is in good condition. It is not in imminent danger of failure. The purpose of this project is to implement preventative measures to extend the safe service life of the dam for the next 100 years and to prevent problems later on. The dam is inspected annually by the Public Works Department, and by Massachusetts state law is inspected by a professional engineer every 2 years. It's regularly mowed and maintained. A 2015 assessment of the dam found that it has an overall condition of fair, with some minor erosion occurring on the back and front slopes of the embankment and seepage occurring along the toe of the dam. Emily Lewis will explain the resource concerns for this project.
Thank you, Charlie. I'm Emily Lewis, environmental planner, and been working on the various resources. So we first began looking at these with the scoping meeting back in January, and then determining which ones are relevant to the proposed action or the preferred alternative that we will present later on this evening. Next slide. So we have them in 3 general groups, and shown here is some of the existing information for these different concerns. So this is soils and water. And so some of the things that we look at are what type of riparian areas or wetlands are within the vicinity of the dam. And some of these include riparian areas along the sides of the retarding pool and the inlet and outlet channels. We note that Spring Brook and its tributaries within the project area. There are wetlands within the project area. And it's a sole source aquifer, which means it's within a sole source aquifer, which means that it's within important area of drinking water for the town of Walpole. Next slide. So our next group is plants and animals. So we worked with the state of Massachusetts to identify if there are any endangered and threatened species in the area. The area has potential for northern long-eared bat, meaning that could be habitat area. And other than that, there were no unusual or invasive animal resources within the project area, just some of your typical wildlife, such as rabbits and squirrels. Migratory birds utilize the area. There are some forest resources, some invasive plant species, and in general, the plants are in a healthy condition. Next. And then social and cultural. We have a cultural specialist that takes a look at any historic sites that are within the project area. And we've noted that there are 3 within a 1-mile buffer, which we want to particularly take note of once we move into determining what areas might be utilized for construction. Take a look at land use, any parklands or recreation that occur, noting that this is adjacent to the Springbrook Conservation Area and the Walpole Country Club. And then taking a look at what types of buildings and infrastructure are within the area as well. And I'll turn this back over to Jeff.
Well, thank you, Emily. So the next part of the presentation, we're going to be talking about the formulation process for the alternatives. And it's a very prescribed process, and we follow the principles, requirements, and guidelines for water and land-related resource implementation studies, or the PR&G. And when we're identifying and evaluating various alternatives, we identify into things such as the public benefits of the alternatives compared to costs, the performance against these guiding principles, performance against the formulation criteria, dam safety and things, and also certainly against the ecosystem services and the resource concerns that Emily just highlighted for us. And before we go too much further, we did want to share with folk on how these costs are shared between federal and non-federal, or federal and sponsor. And as Carl indicated at the beginning of this presentation, the dam is owned by the town of Walpole, and the town as the owner is also serving as the sponsor. So the federal government, in this case NRCS, Natural Resource Conservation Service, their cost share, they're paying for 100% of the planning costs, the cost to date, the assessment report that we mentioned, in this current watershed, supplemental watershed plan environmental document. As the project moves forward, and assuming that the town continues partnering with the federal government, NRCS will pay for 100% of the costs associated with the design, final design, preparing plans and specifications. Construction engineering and quality assurance during construction is also 100% funded by the federal government. The cost of construction itself, the contractor, the bulldozers, and those types of things, that is a cost share between the federal and non-federal or sponsors. So 65% of the construction costs, we'll talk more about that in a little bit, but 65% of those costs are by the federal government. And you'll see down below under the local sponsor cost share, 35% of those same construction costs are the responsibility of the local sponsor. Now there is opportunities for in-kind credits. The town, does some of the components of that. Any significant permitting costs that would be, above and beyond the normal work that we would do as part of the design would be 100% the responsibility of the town. We don't expect any, but nevertheless. And if there's any land or easement acquisition costs, that's also a local sponsor responsibility under this program. Again, at this planning level, we anticipate all of the work being contained within all of the lands currently controlled by the town for this dam. Charlie will talk to us in just a moment about the so-called FWOFI, which is an acronym for the Future Without Federal Investment, or the non-federal action, because the town does have the option to move forward without federal involvement. And obviously, if there is no federal involvement, the cost share of that is 100% local. Charlie, next slide, please. So the formulation process of the alternatives does begin with the town of Walpole in NRCS. We've been working together here for the past 12 months, as we've said. We identified the deficiencies, the problems, and the need for the action. We've done some detailed technical engineering work in developing these alternatives in conjunction with these PRNG guidelines that NRCS works towards. We've identified these alternatives. Ones that are required is, as we just mentioned, Charlie will speak to a little bit more here in a moment, the future without federal investment, decommissioning of the dam, that is a removal, and the removal of the flood control, non-structural alternatives such as elevating structures out of the floodplain or relocating them, or updated zoning, that is preventing additional or new or future. Certainly structural rehabilitation, repairing the dam so that it meets both Massachusetts state dam safety and federal design criteria, NRCS design criteria. The locally preferred alternative, and that's normally aligns with one of these other ones, but we'll talk more about that in a moment. And then similarly, the National Economic Efficiency, or the NEE, which is part of the PRNGs and ensures that we're looking at both, not just costs, but the other impacts of cultural, society, historical, economic, and environmental. So lastly, before I turn the slide over to Charlie, is a criteria for selection, completeness of the alternatives, the effectiveness, their efficiency, and their acceptability. So with that, Charlie will walk us through some of the detail. Charlie, you have the floor.
Thank you. The first alternative that we were required to examine was the future without federal investment, or the no federal action alternative. This alternative includes actions by the dam owner or the town of Walpole to take to correct deficiencies and bring the dam in compliance with Massachusetts dam safety rules. The primary Massachusetts dam safety deficiency includes the inability of the dam to safely pass the half PMF, or the half probable maximum flood. Hydraulic modeling indicates that the auxiliary spillway is subject to significant head cutting or erosion, and a predicted failure through its control section may happen. To correct this deficiency, this alternative consists of armoring the auxiliary spillway with articulated concrete block system, or an equivalent armoring system, to reduce the potential for erosion and to safely pass the half PMF. The estimated construction cost for this alternative was $2.6 million. Of which the town would be 100% responsible for the project cost, as no federal cost share is included in this alternative. Next, the next required alternative we examined was decommissioning, or dam removal. This alternative includes the removal of the flood control function from the dam, reconstructing and restoring the pre-existing stream and floodplain functions. It would involve excavation of approximately 7,400 cubic yards of soil from the dam embankment, demolition and disposal of the concrete principal spillway system, and restoration of the stream and surrounding wetlands. This also involves providing flood protection measures to structures and infrastructure downstream of the dam, including floodproofing buildings, acquisition and relocation of structures, infrastructure upgrades to buildings and culverts, and modifying zoning regulations to address future development in the floodplain. The estimated total project cost is between $7 and $8 million to implement the decommissioning of the project. We have a plan depicting the decommissioning alternative. Washington Street is located at the top of this plan. To the left is the earth and auxiliary spillway, and the dam embankment, which spans from left to right. There's a notch that we have created in the dam where the 7,400 cubic yards will be removed. And that would be to remove the flood control function of the dam and then permanently drain the reservoir. The shaded area is to depict where the stream would reestablish, and the crosshatch is to depict where there would be a loss in that water surface, and you would probably see wetland conversion. Following the decommissioning example, we examined rehabilitation alternatives. These alternatives are to correct deficiencies that do not meet state of Massachusetts dam safety standards and NRCS criteria. The primary deficiencies that do not meet the standards above include the existing auxiliary spillway being activated by the principal spillway hydrograph, a breach through the auxiliary spillway section during the half probable maximum flood and the freeboard hydrograph event. The dam is overtopped during the freeboard hydrograph event, and there are internal drainage issues with the filter compatibility with the surrounding soils and seepage at the toe of the northern portion of the dam. In the prior slide, we identified that the rehabilitation alternatives are required to correct the deficiencies in the dam to meet the federal and state dam safety criteria. We identified 7 structural rehabilitations that could occur at Allen Dam. Alternative 1 consists of raising and armoring the auxiliary spillway with articulated concrete blocks, maintaining the pool at its original water level, and raising the overall top of dam embankment by 9 inches. Alternative 2 and 3 are similar to alternative 1, where we have to raise and armor the auxiliary spillway, raise the dam, and maintain the. But instead, we will be using 2 different auxiliary spillway armoring technologies. One will be with roller compacted concrete, and the other will be with a concrete precast subsurface slab. Alternative 4 is also similar to alternative 1. However, we're going to widen the auxiliary spillway from 120 feet to 155 feet to increase the hydraulic capacity so that we can reduce how much we need to raise the dam. Alternative 5 is similar to alternative 1 as well. Instead, we're going to lower the pool approximately 1.8 feet to provide additional flood storage capacity so that we can reduce how much we need to raise the top of the dam. Alternative 6 consists of constructing a new auxiliary spillway over the dam embankment with roller compacted concrete, abandoning and filling the existing auxiliary spillway, and raising the top of dam by 9 inches. Similar to alternative 5, alternative 7 utilizes alternative 6 and lowering the pool by 1.8 feet to increase that flood storage capacity. All these alternatives include the reconstruction of the downstream toe to address the filter incompatibility with surrounding soils, as well as the seepage occurring at the toe of the dam. As part of our formulation process, alternative formulation process, we need to consider but eliminate alternatives that do not fully meet the PR&G criteria. At Allen Site Dam, this includes the decommissioning of the dam alternative, non-structural alternatives, as well as rehabilitation alternatives 2, 3, and 4. Decommissioning was eliminated because it has a significant and adverse impact to cultural and societal resources downstream of the dam, as well as the cost to implement is 2 to 3 times greater than the cost of the future without federal investment and the retained rehabilitation alternatives. The non-structural alternative, which is similar to decommissioning, includes elevating, floodproofing, and relocating buildings in the downstream floodplain, modifying roadways and infrastructure, and zoning requirements. This was eliminated because it does not address the deficiencies at the dam and may allow the dam to fail in the future. In addition to this, the estimated cost is $10 to $15, which is much larger than the rehabilitation alternatives that we retain. Rehabilitation alternatives 2, 3, and 4 were also removed because they provide the same level of flood protection, but have a higher construction cost. The alternatives that do meet the PR&G criteria and that were retained for detailed study are the future without federal investment or no federal action, structural rehabilitation number 1, which was utilizing articulated concrete blocks for armoring, alternative 5, which is alternative 1 with the lower pool for flood storage capacity, alternative 6, which was to construct a new auxiliary spillway over the dam embankment with RCC, and alternative 7, which was alternative 6, but with a lower pool for flood storage capacity. The next several slides will illustrate the structural alternatives that were carried forward for detailed study. Alternative 1 is depicted on this slide. We have Washington Street at the top of the slide, just to orient everybody. As we discussed, the auxiliary spillway will be armored with ACBs, and the control section will be raised approximately 9 inches. The top of dam, which spans left to right on the page, will be raised approximately 9 inches. The downstream toe will be reconstructed to deal with the filter incompatibility and seepage that's occurring on the northern part of the dam. The principal spillway structure, low-level intake will be reconstructed with new stop logs, and a bridge will be constructed for maintenance to that structure. We also wanted to highlight that the shaded region on this plan is the current existing pond surface level. And for this alternative, it will be maintained. For alternative 5, similar improvements to the dam with the auxiliary spillway armoring, the top of dam being raised, and reconstruction of that toe. This alternative utilizes the reduction of the pond by 1.8 feet, which is the main difference between alternative 5 and 1. That cross-hatched area is area that we expect will need to reestablish wetlands, and the shaded area is where we expect the permanent pool to be established. Alternative 6 utilizes reconstructing a new auxiliary spillway over the center of the dam with roller compacted concrete, a new stilling basin, and reshaping of the downstream channel. Excess material will be used to fill in and abandon the existing auxiliary spillway and to raise the dam embankment. The downstream toe of the dam will be reconstructed for the filter incompatibility and seepage at the northern portion of the dam. Improvements to the principal spillway structure are included. And this alternative utilizes the existing current normal water surface. Similar to alternative 5, alternative 7 will also have a lowered pond and will utilize alternative 6 improvements at the dam. I'm going to send this over to Jeff to describe what we did for a detailed study at the dam.
Thank you, Charlie. So this is just a summary table of these alternatives that Charlie just walked us all through. And I won't drag everybody through all of the details there, but you can see on the left side here some of the different components. And then across the top, we have the no federal action and then the rehabilitation alternatives 1, 5, 6, and 7. Down in the middle of the screen is where we indicate the construction cost and the town's share of those costs. And as Charlie has already said, under the no federal action, we have estimated the cost to repair the dam to meet Massachusetts dam safety standards would be approximately $2.6 million. And with no federal involvement, then the funding would be 100% local. As we move over to alternative 1, the overall construction cost of that project is just over $5 million. But here, because it would be a project that would be under the NRCS program, the town would be paying 35% or approximately $1.75 million. Similarly, with alternatives 5, 6, and 7, and these cost estimates, these alternatives are very similar. One of the reasons they were selected, they're all within the, quite frankly, the margins of error on cost estimating. But there were quite a bit differences in the impacts, particularly draining that pond or lowering that pond in a permanent fashion, as Charlie mentioned. So as we go to the next slide, we wanted to highlight what the sponsors or the locally preferred alternative would be. And folk at the town have stated, as we talked to them, their preferred alternatives. One is that's a least cost to the town. Secondly, it is compliant with state dam safety standards, performance standards. And one that also, ideally partners with NRCS and meets the PRNG and the federal dam safety design criteria. We can bundle all of those together. That would be the locally preferred. Next slide, Charlie. And lastly, then as we go through these different alternatives and we eliminate some and we do a detailed evaluation, we come to the preferred alternative, which is rehabilitation alternative number 1. Charlie just walked us all through that, but I'll just reiterate. That's the alternative that, first of all, maintains the permanent pool where it is now. So it is not a permanent reduction. It requires us to raise the auxiliary spillway control section by approximately 9 inches and armor that spillway, in this case with articulated concrete blocks. Elsewise, it would be subjected to erosion and potential failure during these major storm events. Associated with that is some downstream stone fill to a cutoff trench to help prevent head cutting or erosion. And as Charlie mentioned, we have some work to do with the downstream toe of the dam to extend and repair the existing internal drainage system. This alternative includes repairing of the trash rack and that principal spillway riser, and also the stop logs out in the water where that low level control structure is. Charlie also mentioned this alternative includes a new walkway from the dam embankment out to that low-level trash rack for future maintenance things. There would be some minor or limited removal of accumulated sediment within the vicinity of that low-level outlet. We just get all the accumulated material that's there, so it's functioning again for the next few decades. And clean, repair, and seal all exposed concrete. We want to extend the life of the concrete that's out there. It's in good condition, and cleaning it, repairing it, sealing it up extends that. Charlie, if you would please just walk people through our remaining slides.
Yeah, we just wanted to show another plan of the preferred alternative, which is alternative 1 we've shown before. To orient everyone, Washington Street is at the top of the plan. Again, the auxiliary spillway will be armored with articulated concrete blocks. In the end, we ended up installing a subsurface cutoff wall in the control section. And then we finished the articulated concrete blocks with a stone-filled trench that would be filled with concrete to prevent propagation of head cutting through the auxiliary spillway. The dam would be raised by 9 inches, and the toe of the dam on either side would be filter incompatibility. On the downstream slope where the water discharges, we would be armoring it with stone fill to prevent erosion. And then we would be improving the principal spillway structure. Some sediment has accumulated around the principal spillway intake that's in the pond, and we will be removing that as well. We have a few sections of the dam to show, primarily the middle section here, which shows a section right through the embankment. It's difficult to see, but the existing limits of the downstream slope are right about below this dark black line. So we're not really extending the toe too far downstream, but we need to cut a portion of the dam out and reconstruct this filter material in here to pick up that seepage that's occurring at the bottom of the toe and some incompatibility issues that is occurring in this region. The preferred alternative utilizes articulated concrete blocks. We have a few images here to show you examples of that. In the upper left, we have a crane that's lowering these blocks in. They come on like a bungee system, and they're lowered together, which you can see in the upper right. And eventually, they're concrete grouted together, which you can see in the lower left. And if the town chooses to, or typically what's done is they're covered with topsoil so that you can't see them when they're completed in construction. I'm going to move over to Emily to explain the environmental consequences.
All right, thank you. So as we're going through evaluating all of these alternatives, we're looking at the environmental consequences of each of them as well. And so here we have some of the final consequences we've determined of the preferred alternative. And these include both temporary and permanent impacts, and then other impacts, such as ways that we would mitigate for them or try to prevent impacts. So for the temporary impacts, we'll have some things such as air quality, dust and exhaust that will occur during construction. with the temporary drawdown of the pool for construction, there will be a temporary reduction of habitat and riparian areas. There will be a temporary loss of use for recreation until this is complete. And of course, you'll have views during construction. Will have construction equipment and not quite have that same scenic beauty for a season. The permanent impacts, mostly looking at wetlands, there would be about 0.18 acres of wetland permanently impacted and a few temporary impacts as well. Some minor cutting of trees in the construction area. And then some other things that we will be avoiding are those cultural resources I discussed earlier, making sure we avoid any areas of historic or archaeological sensitivity during construction. Utilizing winter tree clearing to avoid any impacts to potential bat habitat, and then also making sure that construction is done in a way that tries to minimize the potential spread of invasive species. And then back to Charlie once more for some economics.
Yep, we want to go over the economic viability of the preferred alternative. This is done by analyzing the annual benefit of the dam for the difference in damages in the downstream floodplain between the without and the preferred alternative. We do this by using some hydraulic modeling of various flood events through the downstream floodplain with the dam in place, with the preferred alternative, and without the dam in place. In the image you can see on the right side of the slide, the blue region depicts what would be flooded without the dam, and the yellow orangish region is with the preferred alternative. With that information, damages are calculated based on structures, infrastructure, vehicles, valuables downstream, and we get a total estimated annual damage without dam of 2.3 million, and with the preferred alternative of 44,000 for an overall annual damage reduction benefit of 2.35 million. That cost is annualized over 100 years for an annual benefit of the preferred alternative of the $2.3 million. The cost to actually implement the preferred alternative, which Jeff discussed earlier, was a 5 million plus permitting and engineering costs is annualized over 100 years, and is annual cost is 135,900. A ratio between those is about a 17-to-1 benefit to cost ratio. So we'd like to turn it over to Jim Lyons again, and I believe we're going to go into a question and comment period from the attendees.
Great. Thank you, Charlie, Jeff, and Emily. Mike, if you could open it up to the microphones to the attendees. If anybody has any questions, please speak up and we'll be happy to answer them, or if you have any comments as well.
Okay, they're all unmuted. Anybody want to talk, they feel free. We may lose Kyle for a bit. He has to switch to his cell phone, unfortunately. So just giving you guys a heads up.
And if you are wanting to speak, make sure you need to unmic your own microphone now on your computer as well. All right, it's not looking like we have any questions or comments. If people do have questions or comments in the future, you may contact me at Jim.Lyons at and Lyons is Lyons. There we go. Thank you, Jeff. As what's shown on the slide on the screen. And I would like to thank Carl and Jim with the Town of Walpole and Mike for putting together the technical end of things. And again, thank you, Jeff, Charlie, and Emily with DDK. I greatly appreciate your effort on this.
Thank you, Jim.
Thank you, Jim. Jim, I guess is before we just sign off, I didn't know if it might be worth just reminding folk that the public will have, you know, a look at this when the draft environmental documents published next summer.
Yes, we expect that they would be published next summer, yes.
Okay.
Okay, Mike, I think we're done if you want to end the meeting.
Okay, folks, after I get this uploaded to YouTube, I'll send it over to Carl and he can email it off to you guys for your records. And then eventually it will be posted to the town website so people can reference it later on if they choose. So
Thank you,
from
Mike.
here,
Great, thank you very much.
have a good night.
Good night,
Everybody have a
everyone.
great night.